get into a little more detail about numbers in Python. So as I said in the previous video, Python has three basic types of numbers. It has integers, floating point numbers, which correspond to the reals of mathematics, and complex numbers, which roughly correspond to the complex numbers of mathematics. Again, just a reminder that these sets of numbers in reality are infinite, and we do not have infinite representation in Python. There are some additional types of numbers for specialized applications. So there's a module decimal, which will allow you to work with fixed precision numbers, such as currency, where you would have 2 decimal points representation. There's also a fraction module which allows for exact representation of rational numbers. We won't be dealing with either of these packages, but if you are going to do something with currency, you might want to be familiar with that. Okay, kind of an esoteric topic, and not something that will really come up too much in biomedical computations, but you would actually see a fair amount in kind of more computer science oriented things. Are the integers can be coded in decimal form, which would be a base 10, a hexadecimal, which uses base 16, octal, which uses base 8, and binary, which is a base 2. And base 10, our normal counting base, since we have 10 fingers, is the default. And the reason that you have these binary, it relates to the fact that underneath, lying under all of this, the computer is really a binary system with on-off, 0, 1 in the hardware. And octal, the base 8, relates to the fact that a byte is 8 bits in a computer, and hexadecimal, base 16, 2 bytes in older, going back quite a long ways, 2 bytes would have made up a word probably. So these will be numbers, different base systems, more of a computer science value and less of an informatics and scientific computing purpose. But you should just again be familiar with them. So a hexadecimal number is a base 16, so we need 16 symbols to represent the different values that any position in the number can take. And so in addition to our 0 through 9, we have A, B, C, D, E, and F, which are used to represent numbers. So F would correspond to 15. And we can define them with a 0x preceding the number. So here we define the number in a hexadecimal base 16 system, but when we printed it, it rendered it in a base 10 system. Okay, octal. Again, so we would encode an octal number by a 0 followed by an O. We only have 8 digits, so our digit characters are limited to 0 through 7. And here we can define an octal number 547, which corresponds to the decimal number 359. If I try to do this, I'm going to get a syntax error because the symbol 8 is not part of our octal number system. It only goes 0 through 7. Binary numbers, very similar. We can encode them by a 0b. And again, binary, we only need 2 digits. So our digit characters are limited to 0, 1. So here we are defining the number. This corresponds to 2. And this corresponds to 5. So when we add them together, we get the number 7. So we can convert between the different base systems using the functions bin, oct, and hex. And in this case, then it's going to, so here we're taking a decimal number, 2016, and we're rendering it as a hex and printing it. This is the value we get as our output. So Python provides an int function, and here is a link to the documentation on the python.org website. An int is used for converting numbers or strings to integers. The function takes an optional keyword argument, and we'll get more into positional and keyword arguments when we talk about functions. But essentially, it will allow us to specify what base the string is coded in when we go to convert things to an integer. So let's look at some of the behaviors here of the int function. So in this case, we're taking a floating point number, 4.8, converting it to an int and printing it. In this case, we're taking a string, 67, converting it to an int and printing it. So here we're getting 4 and we're getting 67. So the first thing to notice is that the integer function is truncating the floating point number. So it's not doing a rounding function, it's just dropping any of the decimal portion of the number and returning just the integer portion. If we try to do this, we take the string hello and try to convert it to an int, we get a value error because the Python cannot figure out any base, any way of taking hello and making a meaningful number out of it. Here we are telling Python that this string is encoded in base 16 or hexadecimal. Same here, but if we take that same string, 45, and represent it, say that it's encoded in base 8, then we get a, well, that's not the same number because we got this D as the representing the number 13 in that hexadecimal, so sorry for that mistake. All right, floating point numbers. We could create a variable as a floating point either by typing it as with a decimal or explicitly converting it to a float. So in this case, we see as we type a 4, Python is going to, by default, encode that as an integer. If we just type a decimal point, then it's going to represent it as a float or a decimal point 0. Those should be equal valued. We can also use an exponential form. So this is 4 e to the 1. So that should give us 40 because that's that's basically saying 4 times 10 to the power 1. And we can use a lowercase or an uppercase e for that format. Ways we can get floats in Python. We can divide two integers. So if we took 9 divided by 3, we will get a, I start saying that, I'm not actually sure if it's true, but if I take 9 divided by 3, yeah, I'm always going to get a float in return for that division operator. So I get a float by dividing two integers. This is different than Python versions 2, where you would get an integer with truncation. Similar to the int function, Python provides a float function that will take a number or string and convert it to a float. And here you see we get an error that the strings need to be encoded in a decimal format for the floating point operator to work. So one thing we could do is we could first convert that to an integer and then convert it to a float, which you get there. Okay, constructing complex numbers in Python. Python uses the symbol J, lowercase or uppercase, to denote the imaginary part of a complex number. And so we can either type numbers in this format where we're attaching a J to the number, and this will be recognized as a complex number, or like the int function and the float function, there is a complex function where we pass the real part of the complex and the imaginary part of the complex number, and it will construct it for us. All right, and so once we have a complex number, they have a real and imaginary component. These can be accessed independently through the attributes of the number. And just out of kind of jumping ahead a little bit here on our topics for the class, every one of these numbers, let's see, so if I create a number a equals 4, a floating point number, insert a cell below there, that number has different attributes because everything in Python is an object, and objects have attributes and methods. And so here is the real part of a real number. Oops, let me delete that. I'm using tab completion to bring up the different representation, different attributes or things that Python knows about this floating point number 4. Okay, what can we do with numbers? We can do all the basic arithmetics. So we have a plus, subtraction, multiplication, division, modulus, which is a remainder function, and exponentiation, which is a double asterisk. Cameron was pointing out that most other languages use a caret symbol. Just remember in Python it's a double asterisk. So here we're just kind of playing around with different kind of operations where we're starting with these integers and then ask what type. So if we add numbers that are both integers, we get integers in return. If we take a floating point number and we take the modulus 2, we're getting a float. So as you mix things around, so if I take for instance, if I take a floating point number and I multiply it by an integer, my result is going to be a floating point number. So that's called typecasting. So Python there's rules, and you can read up on the documentation. But essentially, it's going to up the result to what the most informative representation of the number. So floats have precedence over integers. Complex has precedence over floats. So if we're mixing those types, it's essentially which numeric type requires the most number of bytes to represent it. And that's what the end result is going to come out as. Okay, these operators have order of precedence that are very similar to what you would have learned in your high school mathematics. Rules for this precedence are described from this link here. Just to note that expressions that have equal precedence are evaluated from left to right. So in this case, multiplication and division have equal precedence, but the multiplication here would be done first and then the division, whereas here division would be done first and then multiplication. We get the same results. Like I said, what happens when you mix types? Find the rules on that. And Python also provides a round function for floats. The round function is not defined for complex. And this is something different than the int function. So it's going to round up to the closest integer value, but the actual value that's returned is a floating point. Oh, I just lied. Let me see what type we actually do get here. You do get an integer. So in this case, instead of the truncation effect, you're getting a rounding effect. We can compare numbers. This first line is going to be an important point, that you compare numbers or variables with a double equal symbol, not a single equal sign, which is an assignment operator in Python. This will be a frequent mistake that you'll make at the beginning. But we can ask whether something is equal, whether it's not equal to, less than or equal to, greater than or equal to. So this right here is an error because the single is an assignment, so we're trying to assign the value 4 to the value 5, which is not valid. So if we really want to make the comparison, we do the double equal sign, and we see that 5 is not equal to 4. So what are some of the important numeric libraries in a standard Python distribution? Well, there's a math module, and this provides definitions of a variety of mathematical functions and constants, such as pi. There's a complex math package that provides complex versions of the various functions, very similar to what's defined in the math function. So for instance, there's a complex square root function that allows you to take the square root of negative numbers, whereas the square root of negative numbers is not defined in the math module. And there's a random module that has different pseudo-random number generators that you can work with. If you want to learn more about the different modules, you can import them into your program, and you can use help, or you can use the dir function as it's a directory listing. It's listing what is in that module. And so here we see we got arc cosines, hyperbolic arc cosines, absolute values, factorials, floor functions, etc. And if we look at what's in the random function, in this case I'm using the help function, this is going to give a nice description of the contents of the module, including any variables, functions, etc. that are defined in it. I'll scroll way down here to get through that. And just kind of playing around with, you can generate random numbers selected from a uniform distribution over a specified range, Gaussian distributions, etc. So lots of there to play with and explore.